Continuing my series on the U-sub integral techniques, I will show you 3 more examples today. So we're going to start firstly with this example right here. So I'm going to say I is equal to 4x times 5 minus 3x squared. This entire argument to the 5 dx. Now you could, in theory, develop this, right? Break it up into multiple parentheses and keep multiplying. But that is excruciating and it's very, very long to do. The U-sub technique is a very useful technique in this situation. So in the previous video, like I showed you guys, the U-sub is used to replace a certain part of the argument with the variable u. You can use any variable, but we just typically use u in calculus. So in this case, we'll say that u is equal to 5 minus 3x squared. We're going to take the derivative of both sides. So the derivative of u is just 1 times du, so du. And the derivative of 5 minus 3x squared is just minus 6x dx. Okay. I'm going to do something here that we don't typically do in calculus because it's not true that you put them on both sides of the variable, but I'll write this thing right here. Du over minus 6x dx. So this is equal to that. Remember, we have our dx right here. It's right here. So this whole problem right here is to kind of find the key between the du variable and the dx one. So let's continue. Right here, we'll have 4x. This entire argument becomes u to the 5 du over minus 6x. And as you can see, the x's cancel each other out very easily. In theory, you're not really supposed to be putting x's under the same integral as the u's, but I'm just showing it visually for you guys so you can see it instead of me just doing it in one step, right? So you can see that the x's cancel anyways, which is kind of the beauty of using this technique. As we know, we can also take the constants out of the integral. So we'll have 4 over minus 6 times the integral of u to the 5 du. And this is one of our base formulas because we know that the integral of x to the r dx is just equal to x to the r plus 1 over r plus 1 plus c. Right, so this one's very easy for us to do now. Let's get rid of this. So we have 4 over minus 6 times u to the 6 over 6 plus c. Remember, we're adding 5 plus 1, which is 6, over 5 plus 1, which is 6 again. So right here we have 4 over negative 36 times u to the 6 plus c. Perfect. Now we can reduce this, obviously. That's negative 1/9 times u to the 6. And as I mentioned in my previous video, if we have an integral in the beginning that's in the form of x, so dx, we kind of are expecting, it's not really explicitly said, but we want x in the end in our answer too, which is really easy here because the key to bring this problem back to the x form is that we have u is equal to 5 minus 3x squared. So wherever you see u in your final answer, you just replace that with your original argument of x. So we can have it here, we say negative 1 over 9 times 5 minus 3x squared to the 6 plus c. Now you can put it on top as the numerator. It won't really change anything. It's the right answer right here. So that's pretty much right here the answer for the integral of this argument right here. Awesome. Let's go do number 2. Let's do another example right here. I've prepared for you guys. So right here we have this one right here. So I2 is equal to the integral of x to the 3 minus 4 x dx. Now, if we look at this argument and we try to do u sub here, we're going to kind of get into a problem. I'll show it to you anyways, but this isn't what you want to do. You don't want to use the u sub here, because sometimes we become very accustomed to a technique and we just try to apply it brainlessly to all the subsequent problems we'll see. But in this case, you really don't have to do that. But I'll show you what happens if you do use the u technique and why it's not super optimal. So hypothetically here we have, we have an argument, x to the 3 minus 4. We replace this with u, x to the 3 minus 4, and we take the derivative of both sides. So du is equal to 3x squared dx. And we try to plot this back into our argument. So we'll have d over 3x squared is equal to dx. We kind of get to a roadblock right here. So what happens here is we'll have u, this whole thing, times x over times du over 3x squared, which gives us something like 1 over 3 u over x, because one of the x's gets simplified at the top, times du. And this right here didn't do anything for us. It's actually making our life more difficult. So the key to actually solve this problem is a lot easier than it may seem. That's why you really just have to look at it for a second before you just jump into integrating and applying all these different techniques. We can distribute, right? We know that integrals have the property of being able to be broken up into the plus and the negative sums. It's true to say that the integral example of x to the 3 plus x dx is also equal to these two integrals, x to the 3 dx plus x dx. So let's apply the same logic here, but right here we have to distribute first. So we'll say, well, this is x to the 4 minus 4x. Remember, always use the parentheses because we want to apply the dx to both, correct? And then let's break these up into two integrals, x to the 4 dx minus 4 x dx. I skipped a step here, but you can always remember you can take your constants out instead of leaving them in. We know how to integrate both of these arguments. Very, very easy, just the power rule. So we'll say x to the 5 over 5 plus c1, because the first constant of this integral, minus 4 times x squared over 2 plus c2. The c1, c2, not really necessary. You could just write c. I'm just showing it that example if I hypothetically had one that solved way before the other one. I need to write that's the first constant and not the second one. But if you solve these both in one step, you can just add the c right away. This continues, so it's x to the 5 over 5 minus 2x squared plus c. So that's the answer to this integral. A lot more simple than it looks. So you really just have to take a step back at times and just analyze what you're really doing. Now for the final example. We had one right here that I wanted to do. Right here, perfect. So I is equal to the integral of 5 cosine of 3 theta d theta. Now this one right here, we know that the integral of cosine of theta is just equal to sine of theta. Right? So this one we don't really know right away what it can give us, but like I said, we have the u sub. So if we put u is equal to the argument of the cosine, so we say u is equal to 3 theta, du is equal to 3 d theta. So du over 3 is equal to d theta, right there. Very easily, we put this under our argument, so we'll have the integral of 5 cosine of u, because we replace that from our 3 theta, times du over 3. remember we can take constants out of our integral. So we can say 5/3 integral of cosine u du, which is equal to 5/3 times sine of u plus c, right? Because this is one of our base forms. We know how to do this one. Now, like I said previously, we ask the answer under 3 theta, or we ask it under theta form. Put it back in that form. So you can't leave it under u. When your prof will ask you a type of question like this, if you leave it under u, yes, you got the integral right, but you forgot the easiest step, and you're going to lose points on an exam for that. So you do 5/3 times sine of 3 theta plus c, right there, and that's your answer. So we have 3 different integrals to do, all different techniques. This one was the U-sub, and very clearly simplified with something else. Right here was a little bit of a trick. You have to really think about it before, not blindlessly just put the U-sub down. And this one was very easy as well. But just some very good introductory examples to get you started on this type of technique. So thank you for listening, and have a nice day.